Hi everybody, in this video also we are discussing the questions from JEE Main 2024 entrance examinations. These questions are also from the chapter Chemical Kinetics. Now question number 1, you please listen. Consider the following transformation involving first order elementary reaction in each step at constant temperature as shown below. The given equation is A plus B reversibly gives C giving P. In the first step, in the reversible reaction, the forward reaction is represented by step 1 and backward reaction is by step 3. And the equation C giving P is represented by step 2. The details of the reaction are given in a chart having 3 columns. In the first column, step numbers are represented. Second column, rate constant in second raised to minus 1 is represented, and in third column, activation energy in kilojoule per mole is represented. In step number 1, rate constant is K1 and activation energy is 300. In step number 2, rate constant is K2 and activation energy is 200. In step number 3, rate constant is K3 and activation energy is EA3. If the overall rate constant of the above transformation K is equal to K1 into K2 divided by K3, and the overall activation energy in bracket EA is 400 kilojoule per mole, then the value of EA3 is dash kilojoule per mole in bracket nearest integer. Listen here, according to Arrhenius equation, rate constant of a reaction K is equal to A into E raised to minus EA by RT, where capital A is a constant called Arrhenius constant or Arrhenius parameter, EA is the energy of activation of the reaction, R is a gas constant and T is a temperature in Kelvin. Here in this question, the given equation is A plus B reversibly gives C giving P. In the reversible reaction, the forward reaction is represented by step number 1 and backward reaction by step number 3, and the equation C giving P is represented by step number 2. Now we can write for the first step, rate constant K1 is equal to A1 into E raised to minus EA1 by RT. This is equation number 1. And for the second step, K2 is equal to A2 into E raised to minus EA2 by RT. That is equation number 2. And for the third step, K3 is equal to A3 into E raised to minus EA3 by RT. This is equation number 3. Now equation number 1 into equation number 2 divided by equation number 3 gives K1 into K2 by K3 is equal to A1 into A2 by A3 into E raised to minus of EA1 plus EA2 minus EA3 by RT. But here it is given that rate constant of the overall reaction K is equal to K1 into K2 divided by K3. Now according to Arrhenius equation, rate constant of the overall reaction capital K is equal to A into E raised to minus EA by RT. Then substituting A into E raised to minus EA by RT instead of K1 into K2 divided by K3, the equation becomes like this. From this equation, it is clear that energy of activation of the overall reaction EA is equal to EA1 plus EA2 minus EA3. Here EA is given as 400, EA1 is 300 and EA2 is 200. From this equation, EA3 can be calculated, which is equal to 100 kilojoule per mole. So here the answer is 100. Now question number 2, please listen. Consider the following reaction, the rate expression of which is given below. The reaction is A plus B giving C, and the rate expression is R is equal to K into concentration of A raised to half into concentration of B raised to half. The reaction is initiated by taking 1 molar concentration of A and B each. If the rate constant K is 4.6 into 10 raised to minus 2 second raised to minus 1, then the time taken for A to become 0.1 molar is dash seconds in bracket nearest integer. Here in this question, rate of a reaction is given as R is equal to K into concentration of A raised to half into concentration of B raised to half. So the rate law equation is this one. Now we can calculate the order of reaction. Order of a reaction is defined as the sum of the powers of the concentration terms present in a rate law equation. Here in this equation, the concentration terms are concentration of A and concentration of B, and their powers are half each. So the order of reaction N is equal to half plus half, that is equal to 1. Therefore, it is a first order reaction. For a first order reaction, the time taken for the reaction T is equal to 2.303 divided by K into log initial concentration R0 by final concentration RT. Here K is given as 4.6 into 10 raised to minus 2 second raised to minus 1. Initial concentration R0 is equal to 1 molar and the final concentration RT is equal to 0.1 molar. Then substituting these values in this equation, the equation becomes T is equal to 2.303 divided by 4.6 into 10 raised to minus 2 into log initial concentration 1 molar and the final concentration is 0.1 molar. This is equal to log 10. Log 10 is equal to 1. Therefore, T is equal to 2.303 divided by 4.6 into 10 raised to minus 2. That is T is equal to 50 seconds. So here the answer is 50. Now question number 3, listen please. During kinetic study of a reaction 2A plus B giving C plus D, the following results were obtained. Here a chart is given, consists of 4 columns. The data given in different columns are column number 2 concentration of A in molar, column number 3 concentration of B in molar, and column number 4 initial rate of formation of D in moles per liter per second. In the first case, concentration of A is 0.1 and that of B is also 0.1. Then initial rate of formation of D is 6 into 10 raised to minus 3. In the second case, concentration of A is 0.3, that of B is 0.2 and initial rate is 7.2 into 10 raised to minus 2. And in the third case, concentration of A is 0.3, B is 0.4 and initial rate is 2.88 into 10 raised to minus 1. And in the last case, concentration of A is 0.4, B is 0.1 and initial rate is 2.4 into 10 raised to minus 2. Based on the above data, the overall order of reaction is dash. Listen here, this is a data given in the question. Now we can write a general equation for the rate of reaction, that is R is equal to rate constant K into concentration of A raised to X into concentration of B raised to Y. We need to find out the power of concentration of A and the concentration of B, that is X and Y. Then the order of reaction N is equal to X plus Y. Now we can substitute the values of initial rate, concentration of A and the concentration of B from the given data. We will get 4 different equations, that is equation number 1, equation number 2, equation number 3 and equation number 4. If we divide equation number 3 divided by equation number 2, that is 2.88 into 10 raised to minus 1 divided by 7.2 into 10 raised to minus 2 gives 4. Here these two are common terms, cancel each other. Then 0.4 divided by 0.2 is 2 and its power is y. Therefore 2 raised to y is equal to 4. 4 is equal to 2 square. Therefore y is equal to 2. Then if you divide equation number 4 by equation number 1, that is 2.4 into 10 raised to minus 2 by 6 into 10 raised to minus 3, that is also 4. Here K and 0.1 raised to y are common terms, they cancel each other. And the remaining 0.4 divided by 0.1, that is 4 and its power is x, that is 4 raised to x is equal to 4, that is x is equal to 1. We know the order of reaction N is equal to x plus y. Here x is equal to 1 and y is equal to 2. Therefore, order of reaction is 3. So here the answer is 3. Now question number 4. Listen please. Consider the following single step reaction in gas phase at constant temperature. 2A gas plus B gas giving C gas. The initial rate of reaction is recorded as R1 when the reaction starts with 1.5 atmosphere pressure of A and 0.7 atmosphere pressure of B. After some time, the rate R2 is recorded when the pressure of C becomes 0.5 atmosphere. Then the ratio R1 is to R2 is dash into 10 raised to minus 1 in bracket nearest integer. In this question, the given reaction is 2A gas plus B gas giving C gas. The initial pressure of A and B are given, that is when time T is equal to 0, pressure of A is given as 1.5 atmosphere and that of B is 0.7 atmosphere. At that time no C is formed, therefore its pressure is equal to 0. We know that pressure of a gas is directly proportional to number of moles, so we can assume that the initial number of moles of A given is 1.5 and B is 0.7, then C is equal to 0. After a time T, it is given that the pressure of C becomes 0.5 atmosphere. That means 0.5 mole of C is formed from the reactants A and B. According to equation, 1 mole of C will be formed from 2 moles of A and 1 mole of B. Therefore, the number of moles of A reactor will be equal to 2 into number of moles of C formed. Number of moles of C formed is equal to 0.5 into 2 is equal to 1 mole. Therefore, number of moles of A remaining is equal to 1.5 minus 1. Here number of moles of B reactor will be equal to number of moles of C formed, that is equal to 0.5. So number of moles of B remaining is equal to 0.7 minus 0.5. That is the final pressure of the reactants and products will become, that is for A it is equal to 1.5 minus 1, that is 0.5 atmosphere. For B it is equal to 0.7 minus 0.5, that is 0.2 atmosphere. And C is equal to 0.5 atmosphere. We know the rate of reaction R is equal to rate constant K into pressure of A square into pressure of B. Then substituting the values of pressure of A and pressure of B when time T is equal to 0, the equation becomes R1 is equal to K into 1.5 square into 0.7. This is equation number 1. After a time T, the equation becomes R2 is equal to K into 0.5 square into 0.2. This is equation number 2. Dividing equation number 1 by 2, that is R1 by R2 is equal to, here K cancel each other. 1.5 divided by 0.5 is 3, its power is 2. 0.7 divided by 0.2, that is 7 by 2. So R1 by R2 is equal to 9 into 7 by 2. This is equal to 31.5. That is equal to 315 into 10 raised to minus 1. So here the answer is 315. Now question number 5, listen please. The time required for 99.9% completion of a first order reaction is dash times the time required for the completion of 90% reaction in bracket nearest integer. Here we know for a first order reaction, the time taken for the reaction T is equal to 2.303 by K into log initial concentration R0 divided by final concentration RT. So T 99.9% is equal to 2.303 by K into log initial concentration can be taken as 100. After completing 99.9%, the final concentration becomes 0.1. So this is equation number 1. Then T 90% is equal to 2.303 divided by K into log initial concentration again 100. After completing 90%, the concentration becomes 10. So this is equation number 2. Dividing equation number 1 by 2, that is T 99.9% divided by T 90% is equal to log 10 raised to 3, that is 100 divided by 0.1 is 10 raised to 3 divided by log 10. This is equal to 3. That is T 99.9% is equal to 3 times T 90%. So here the answer is 3.